All right, guys, so in this video, we're going to be going over Lesson 1's notes for Unit 11. Really quick, though, geometry, this is Unit 11. We're going to be talking about probability and statistics. Today, like I said, it was Lesson 1. We're going to be talking about sets, subsets, Venn diagrams, and probability. And then afterward, we're going to have a little bit of practice on pages 7 and 8. Just to show you a little heads up of how this unit's going to go. This is a longer unit. We're actually going to have 3 quizzes for this one. So this upcoming Friday, or Thursday, Friday, the 28th and 29th, we're going to have our first quiz. Then we got spring break. And then when we get back from spring break, we're going to be doing a bunch of notes. And then Tuesday, Wednesday, the 16th and the 17th, that's our second quiz. Monday, the 22nd, that is quiz 3. That following block is going to be review, and then Thursday, Friday, 4, 25, and 26 is Unit 11 test. And then the Thursday, Friday, May 2nd and 3rd is going to be our 4th 9-week reassessment opportunity. This is going to be the last test retake chance that you can have, and it's going to be, you can choose from Unit 10 or Unit 11, okay? Also, don't forget Delta Math. If your teacher decides to grade you based on that, make sure that you get that done before you walk in for your test. All right, so just as a quick warm-up, it says you spin the spinner shown. There are blank possible results. So if we look at the spinner, we can see that there's numbers ranging from 1 to 10, and we kind of slice it up into 10 slices, right? So that means that there's going to be 10 possible outcomes. Now it says, what is the probability of spinning a 4? Well, there's only one slice that has a 4 on it, so the probability of spinning a 4 is a 1 out of 10, or sometimes you might see it as 0.1 or 10%. Now it says, do you have a greater chance of spinning an even number or spinning a multiple of 3? So with this spinner here, let's try and think like, okay, how many of these numbers are even? Okay, so probability of an even number. So if I look at the spinner, I've got 2, 4, 6, 8, and 10. So that means I've got 5 different even numbers out of 10, which is 0.5 or 50%. And now for a multiple of 3, if we look at that, we only have 3, 6, and 9. So there are 3 out of 10 possible outcomes, or 0.3 or 30%. So you're more likely to spin an even number than you are a multiple of 3. So sets, subsets, Venn diagrams, and probability. It says the probability is the extent to which a certain blank or blank is probable. All right, so a certain outcome also known as an event, is probable. And we have a formula for this. It says P, and then inside parentheses is A. So let's say we have an event called A. P of A just means the probability of A. So probability of event A. That's equal to the number of ways event A can occur divided by the total number of possible outcomes. So like in our warm-up, we said there is a 1 out of 10 chance that you land on a 4, or there is a 5 out of 10 chance that you're going to spin an even number. Okay. Just a couple of quick definitions here. The set of all possible outcomes is going to be your sample set. Okay, so for example, like if you had the sample set for rolling a die, right? The possibilities are 1, 2, 3, 4, 5, or 6, all right? So that would be your sample set. Now within that set, you have things called, or within that sample set, you have things called elements. Elements are just a member or item in a set. So like if you're looking at the probability of rolling a die, like we said, it would be options 1, 2, 3, 4, 5, or 6. 1 would be an element within that set. Now, a collection of numbers, geometric figures, letters, or other objects that have some characteristic in common, okay, this is a set. This is the definition of a set. So, for example, set A contains elements 1, 2, 3, 4, 5, and 6. And we typically use these little brackets to denote the ends of it. Like we just kind of contain all the elements within those brackets. The next thing, now sometimes you might have a set within a set, all right? So this is called a subset. So a subset is a set in which every element is also contained in a larger set. So for example, if you're looking at set A, you have elements 1 through 6. Well, you might have even subset, elements 2, 4, and 6. All of this even subset is inside the bigger set, all right, set A. Same thing with the odd subset. You have elements 1, 3, and 5. These are also all contained within set A. So these are two examples of a subset of set A. Now, the probability of an event happening is written using P event. So this is where typically when we're talking about sets, we're going to be looking at the probability of events happening or this set happening. So the probability of an event happening is written using P, and then inside parentheses, you put the event, all right? So an example of this is the probability of rolling an even number on a dice. Well, what are all the total outcomes? So sample space is 1, 2, 3, 4, 5, and 6. Well, an even number, we only have 2, 4, and 6. So that's 3 out of the 6 total. All right, so the probability of rolling an even number is 3 out of 6, or 50%. Now, if you're trying to create a sample space, so in our first example, our sample space is all the colors we could land on when we spin the spinner. So we got a spinner here. And so our sample space is blue, yellow, red, and green. Another example of this would be, what would be the sample space for rolling a standard die? So like we said earlier, the outcomes are 1, 2, 3, 4, 5, and 6. And now it says, what would be the sample space for rolling 2 4-sided die? So I've kind of started already filling it in, but for example, if you have 2 4-sided die, so here's 1, here is 2. These are the sample spaces for each die, right? And now since I'm rolling 2 of them, the outcomes could be 1 and 1, or it could be 1 and 2, 1 and 3, 1 and 4, or 2 and 1, 2 and 2, all the way down, all the way up to 4 and 4, right? So this sample space is a lot bigger than if we were just rolling 1 6-sided die. Now, a way that we usually visualize sets and subsets and all those things, we use what are known as Venn diagrams. So diagrams like these make doing the math much easier because we can see the whole situation at a glance. So for example, we have a Venn diagram that was used to sort the letters of the alphabet. And so you got 26 letters. It says, what is special about the grouped letters in the circle? So we've got this box that contains all the letters. Most of them are right here, but then some of them are inside this circle, okay? We typically use a circle to represent a set. And inside this set, V, we have A, E, I, O, and U. And if you notice, those are all the vowels in our alphabet, okay? So what's special about the group letters in the circle? They are all vowels. Now it says we call the set containing all possible outcomes, okay? So every single thing that could possibly happen, we call this the universal. The universal set. Now, we call any set within a larger set a subset, remember. Okay, so if you see something that's a set that is contained within another set, it's called a subset. And now we can say that V is contained within the set E by using the notation V, and then it looks like a C, and then the set E. So basically, this just means set V is contained within set E. That's all of this. These symbols mean. It's just a shorter way to write. Instead of having to write this entire sentence every single time, you could just write this, and it would be much quicker. Now it says, similarly, we can say that specific elements are contained within set V. So you could say, remember we always show elements using these brackets. And so element A is an element within set V. Or you could also say A, E, I, O, and U are elements within V. And we use this symbol right here. It looks like it's kind of similar to that C, except it looks like an E, right? So it's saying this is an element within V. So for example, it says identify the universal set for the diagram. So we've got the universal, and this box right here, right? And it wants us to list all the elements within that set, okay? So U, bracket, contains, and if you look, each one of these numbers are an element. All 10 of them, right? So we've got numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And it says identify the elements in Q. So if I come back over to the Venn diagram, I've got this circle right here is set Q. And each one of these numbers inside of it means that it's part of that set. So Q is equal to 2, 4, 6, and 8. And so it says, what is special about the elements in P? So if I come back over to set P this time, so here's P right here. And I look at all the elements in there. We've got 3, 6, and 9. So you'll notice that all of these are odd numbers, right? Or excuse me, multiples of 3. So it says, what is special about the elements in P? They are multiples of 3. Now it says identify P and Q. So we haven't talked about this just yet, but this is an intersection, and it means and. And we're going to dive into that on the next page, but it really just it's asking, tell me what elements are inside both P and set Q. Okay, so if I come over here, remember how we said everything inside this circle is set P. Everything inside this circle is set Q. So we want to look for all the numbers that sit inside both of those circles. And if you look, the only one that sits inside both is the number 6. So identify P and Q. Just going to put it like this, right there. So P and Q equals element 6. Now it says express that the element 6 is in P and Q. So I'm going to write it as, basically they want us to write 6 is an element within P and Q. So I write 6, and then remember how we said earlier, I'm going to go back a second, it says example, A is an element within V. I'm just going to write this in terms of this problem. 6 is an element within P and Q. All right, so you saw in that last question it was talking about P and Q. We're going to be looking at here a couple different versions of that, all right? So the first one is called the union of sets. And the key word when you're looking at this, a lot of times you're going to see a problem that expresses the question in words. The key word is or. And we use the symbol, it looks like a U, so you think U, union. And an example of this would be like A union B. In other words, what elements are in set A or B. And if you want to look at it as a Venn diagram, okay, if it's in A or B, that just means that it has to sit inside A, or it could sit inside B. So anything inside one or the other. So really anything inside here would be counted as A or B. Now the next one, this is the one that we talked about earlier. It is the intersection of sets. And the key word when you see this would be the word and. So going back a second, you saw in this last question, it said identify P and Q. Okay, and then we said, oh, well, that's element 6. So we use the symbol, it looks like an upside down U on this one. Notice how it's the opposite of union. Okay, so in symbol form, it might look like A, upside down U, B. And that just means what elements are in set A and B at the same time. And just like that last problem, it's where these two circles intersect. That's why it's called the intersection. And then the last thing, so we've looked at elements inside one or the other. We've looked at elements inside both sets. Now, sometimes they might ask you what elements are not in set A, for example. Okay, not in a set. Okay. This is also known as complement. All right, so the key words here, you might see not in set A or B, or you might see the word complement. These both mean the same thing. Now, just like union and intersection, union we used U, intersection we used the upside down U. If you're looking at the complement of a set, there's a couple ways they might do it. Sometimes they might put an apostrophe next to the letter. Sometimes they might put a bar over top of it. So it might look like A apostrophe, or it might look like A with a line over it. You also might sometimes see it, I'm going to add a third one. You might also see it as a little squiggly line right before the letter. So all of these symbols mean the same exact thing. They just mean what elements are not in set A. And so if I'm looking at everything outside of set A is the circle on the left. So it's everything outside of that. So it could be anywhere out here. All right, so just as a couple more examples, it says shade in the Venn diagram, the area of the Venn diagram. So if I'm looking at, remember this is A or B, okay? So long as it sits inside one or the other or both, it counts, right? So here's A, here's B. Anything inside one or the other is okay. This one is A or B or C. So long as it's in at least one of them, it counts. So this one would be A, here's C down here, here's B all the way up here. So anything inside this shaded area would count as A or B or C. Okay, so this one has the line over it, and so that means not an A. So everything that is outside of set A is what we're looking for. So set A, I'm just going to put a circle around it and do everything outside of it. Next one is A and B. So it has to be in both set A and set B at the same time. And so we're looking at the intersection of those two sets. This one is A and B and C, so it has to be in all three of them at the same time. And so if I do that, it'll just be this little tiny intersection in the center. And then this last one, this one is not A and B and C, so you can think of it as the opposite of this one, all right, the complement. So if A and B and C is just this little tiny center, the complement of that, the opposite, would be everything outside that center. All right, now, as an actual practical example, it says how many students play sports year round. So we have a Venn diagram here on the right, and it says it's got three different parts: fall sports, winter sports, and spring sports. And so if they're asking how many students play year round, really we just want to look at the students that play every single sport at this school. So that means they'd have to play it fall and winter and spring all at the same time, right? So in other words, if I were to write this in notation, it's looking at how many are fall and winter and spring. So if I come over to the Venn diagram, I have 3 students that match that description. If I'm looking at this next one, asks how many students play sports in the spring and fall. Okay, so the word and. So I'm looking at students that play in the spring and the fall. So if I come over to the Venn diagram, I got to look at where fall and spring overlap. And so fall is top left, spring is in the bottom. So I'm counting all of these students right here. So 6 and 3 add up to equal 9. It says how many students play sports in the winter and fall? Okay, so the word and. Okay, so winter and fall. On the Venn diagram, that would be this intersection right here. It's where the fall and winter sets overlap. And so 13 and 3 add up to be 16. And then the next one says, how many students play sports in the winter and spring? Okay, so winter and spring. So winter and spring overlap right here. And so 3 and 2 add to equal 5. Next one, it says how many students play only one sport? Okay, so you want to look at each season individually, okay? So this circle right here, this represents all the students that play fall sports, right? This circle right here. But if you look more specifically, the 3 represents they play all three seasons, right? So that one doesn't work. The 13 represents students that play fall and winter, but not spring. So that one doesn't work. The 6 represents people who play fall and spring, but not winter. So that one doesn't work. So the only one inside this circle would be 21, right? So these are students that play only fall. All right? And the same could be said about this 8. This 8 represents only winter. And then same for the 19. This represents only spring. Okay, so if I look at only one sport, that would be 21 plus 8 plus 19. And so that's going to be 29 plus 19 is 48. And then the last one, how many students play at least 2 sports? All right, so you got to look at people who play fall and winter but not spring, fall and spring but not winter, spring and winter but not fall. Okay, so there's 3 different numbers we got to look at here. So I'm going to be looking at the intersections primarily, right? And then the other thing, it says at least, so they could potentially play 3 sports, right? So got 13, that's fall and winter. 6 is fall and spring. 2 is spring and winter. And then 3 is all 3 of them. So for this one, I have 13 plus 3 plus 6 plus 2. So that's 9, 10, 11. That's going to be 24. All right, and then the last thing, it says list the elements in each region described in the following Venn diagram. So remember, this apostrophe means not A. So I want to list all the elements that are not in A. So here's A right here. I want to list everything outside of that. Okay, so everything out here. So if I count up all those elements, I got 10, 2, 28, 21, 6, 15, 35, 22, 3, and 9, right? So I'm going to try and list these in number order. I got 2, 3, we've got 6, 9, we've got 10, 15, we've got 21, 22, 28, and 35. All right, not in B. Okay, so that's everything outside of the B circle. So we're going to have all of these numbers and these three numbers. So I've got elements 1, 2, 6, 8. And you don't have to list them in order. I'm just doing that just because I want to. We've got 10, 13, 15. We've got 21, 28, and 50. Next one, A intersect B. So this is where it has to be in both A and B at the same time. And so we're just looking at the intersection of these two. So we'd have 7, 12, and 30. The U stands for union, so A or B at the same time. So anything inside A or B is going to count. So anything inside here. So we got 1, we've got 3, 7, 8, 9. We have 12, 13, 22, 30, and 35. Next one is, it's got to be in not A and B. So everything that is not in A, but also B at the same time. So you have to look at, you could look at each one individually, or you can look at them as a group. It's got to be not in A, so it can't be, I'm going to cross out A. It can't be in here, but it also has to be in B at the same time. Well, none of this stuff out here is in B. So the only things that satisfy both conditions, not A and B, are these four numbers right here. So we got 3, 9, 22, and 35. Okay, next one, same thing. It's just flipped. It's got to be an A and not B at the same time. So it can't be in B, right? So it can't be anything inside B. But it's also got to be inside A at the same time. So everything outside of A doesn't work. So the only things that work are these four numbers right here. We got 1, 8, 13, and 50. Next one, we've got not A and not B. So it's got to be, it can't be in either one of them. It's got to be outside of that. So not A means cross these out. Not B, cross these out. So the only numbers that are not in either one are these 6 on the outside. So my set is 2, 6, 10, 15, 2, 6, 10, 15, 20, 21, and 28. This one, not A or B. Okay, so the U stands for or. So let's look at each set individually. Whenever it says or, it just has to satisfy one or the other. Okay, so not A. Well, A is this circle, so let's look at that. Not A. So all of these numbers count towards that, right? And then, or it could be in B, right? So first, let me list these numbers really quick. I'm just going to list these out of order. I've got 10 to 28, 35, 3, 9, 22, 15, 6, and 21. All right, so that satisfies not A. Now, the other one, or it could be in B. So everything inside this circle represents B. You just got to be careful. You don't need to list an element twice. So like, for example, I already have element 3 in here. 3 is right here. So I don't need to list it again, all right? So the ones that I've already listed were these 4 right here. I don't need to list those twice, so I just need to list out these ones. So I've got 7, 12, and 30. And then the last one, A or not B. So I can look at each of these individually, all right? A, well, everything inside this circle is inside set A, right? So I've got 1, 13, 50, 7, 8, 12, and 30. And then I want to look at or not B. Well, here's B right here. This circle represents B. So I don't want to look at those numbers. I want to look at everything else. So I've already listed everything inside A, so I don't need to list these 4 numbers again, but I do want to list these 6. Okay, those are the only ones I'm missing from my set. So I've got 10, 2, 28, 15, 6, and 21. Okay, so that's our introduction to this new unit. I know that we've got practice pages 7 and 8. Mr. Robinson has made a video. You can see that linked here on Canvas. Follow along with that video. I would suggest trying to do as much as you can without the video. And then if you get stuck, find that video, click on it, and fast forward to the spot that you're stuck on so that way you can see how he did it.